So the first thing we're going to find here is L. How do we find L? The length. It'll be the three-dimensional Pythagorean theorem. Square root of 0.8 squared plus 0.35 squared plus 0.125 squared. Second square root. 0.8 squared plus 0.35 squared plus 0.125. So 0.882 inches. How many of you had that? You look confused, Robin.
I found the length of
the bottom.
Yeah.
It came out different.
Came up with,
Okay, so if we did that bottom across there, let's just call that length A down there. A would be the square root of 0.8 squared plus 0.35 squared, right? Equals 0.873. That's across the bottom. Now we've got to go this way to find L. So it's going to be square root of 0.873 squared plus 0.125 squared. Now what I'm going to do here is I'm going to keep that in the calculus. I'm going to do the square root, second answer squared plus 0.125 squared, 0.882. Pull out the third dimension. Now for R. R is just this triangle down here, and it is a right angle there. So R is just this angle where this is 0.35 and this is 0.8. Other way, 0.35 over 0.8. Opposite over adjacent. Inverse tangent, 0.35 divided by 0.8. Make sure you close those parentheses. 23.63 degrees. What did you use to find it? I was going to say inverse tangent, if you have 0.35 and 0.8. So you had to grab a wrong number somewhere for that. So you got 66.37. Yep. It's just the complement of that, by the way. One way to double check is you'll always know when you look at this, if these two sides are the same, this angle would be 45 degrees, right? If the opposite side is shorter, it better be smaller than 45. If the opposite side's longer, it'll be bigger. So when you get that angle that's bigger than 45, you look at it and see that it should have been smaller. So that tells you you probably did it backwards. So we've got this here. Find angle T is up here. That's this triangle here in the green now. On that triangle, we have, this is the vertical of 0.125. And this is just L of 0.882. So T has the adjacent and the hypotenuse, which is cosine. So I'm going to use an inverse cosine. 0.125 over 0.882. Now, if this were a precision calculation, I would probably go back to my calculation of the 0.882 and go at least one or two more decimal places. It's 81.85 degrees there. Well, that one, it doesn't depend on R at all. As long as you've got L correct and you use that height, that one works out all on its own. So any questions on that one? Quit putting the numbers in upside down and it'll help you. Or just turn your paper over the other way. Maybe you're doing everything just right, your paper's upside down. I know sarcasm isn't helping.
I appreciate it sometimes.
Okay, sometimes.
No, I did it again. I came up with the right.
Probably just punched a key wrong, hit a wrong number. Okay, so for this one, it's actually more dangerous when they come out close like that than if they come out way off. Because when they're close, it doesn't click right away that it's wrong. So we're looking at this one here. This is a top view. This is going to be our front view. And this will be our right end view over here. This time, however, instead of giving you dimensions as lengths, I'm going to do this. There's the axis of that bore, of that hole. I'm going to tell you this angle right here is 40 degrees. And over here, I'm going to do something similar. I'm going to tell you that this angle right here is 25 degrees. That's all the information I'm going to give you at this point. Believe it or not, it is enough to find at least R and T, the angle of rotation and the angle of tilt. Why can't I find L as well? Well, L would be a length, and I'd have to have some sort of a length dimension to find another length. Remember, we talked about this in triangles. The angles can all be the same. Once you know the angles, one angle, you can find all the other angles. It's the dimensions that you have to have a length to find. So taking a look at this, what I am going to do is I am actually going to choose a thickness. A height, in other words, for this. I want to choose one that's easy to use. Just an arbitrary one. So what I'm going to do is I'm going to go into the metric system. And I'm going to choose it to be 10 millimeters. I could be 10 millimeters, it could be 1 inch, 10 inches, it really doesn't matter. Now, based off of that, I'm going to find some dimensions. Those dimensions are totally imaginary, but the angles will still be accurate. Does that make sense? So all I've done is I've picked a size. The figure I find is going to be similar to the figure, the actual figure. Similar means all the angles are the same, but the lengths will all be, proportional depending on the length. So it'll be blown up or shrunk down. But now based off of that, what I'm going to do is I'm going to come over here and I'm going to look at this triangle here. This is actually going to serve as my height now for my figure. I can find this here, which is my width. What do I mean by height, width, and all that happy crap? Remember, I've got this box and my bore goes from here to here. This is my height. I'm saying this is 10 millimeters here. That's my height. This is my width, what I find there, and this will be my length, which I'm actually going to find from over here. So this width here, if this is 10 millimeters, how do I find that width? Well, the tangent of 25 degrees equals W over that 10, right? Come on. I do that and I cross multiply and divide. Tangent of 25 times 10 is 4.663. So that width is 4.663. Over here is the same thing. I'm looking for L. Well, off that 40 degrees, that's the opposite side. I know this is 10 millimeters here. That's the adjacent side is tangent again. Tangent of 40 equals L over 10. So I put that over 1 and I cross multiply and divide. Tangent of 40 times 10. 8.391. So I now have my length, width, and height. This is now the exact same problem we just solved. R is right there. R is going to be the inverse tangent of this dimension, which is the 4.663, over this dimension, which is the 8.391. .06 degrees. T, this angle here, going to require just a touch more work. To find T, I'm going to find the theoretical length of that. That theoretical length, of course, is the square root of ten squared plus 8.391 squared plus 4.663 squared. 13.862. Now, that is not the actual length of that by any means. It's just a theoretical length. If it were actually 10 millimeters thickness. But now I can use that to find T, because T is the inverse cosine of that 10 millimeter height, that would be 10 millimeters here, over that hypotenuse of 13.862. .83 degrees. Now, I'm going to do another problem like this. I'm going to do it slightly different because I want to do it in such a way that it'll allow us to develop a formula if you want to use formulas. We all know that I don't like memorizing formulas, but I show them to you so you have them in case you want them. But we'll develop a formula that you can use without having to pick that height if you don't want to. Now, if you're given that height or that thickness, then the rest of this, if that 10 millimeter thickness were the actual thickness given in the problem, then this actually is the length of the bore. But let's take a peek. And let's say that this angle here, let's call that one 30 degrees. And this one here, we're going to call 20 degrees. I'm going to pick that thickness to be 1 inch. The reason I'm picking it to be 1 inch will be apparent here in just a second. So this is my L, this is my W, and of course, H is the 1 inch. So this is 1, that's my H. How would I find W down here? Tangent 20 degrees equals W over 1, right? Now, if I solve this for W, what I'm doing is just taking tangent of 20 times 1 when I cross multiply, right? So in other words, W is just tangent of 20 degrees. 0.364. That's just the tangent of 20 degrees. Over here, I do tangent of 30 degrees equals L over 1, right? I cross multiply and divide there to find L. It's just tangent of 30 degrees times 1, which is just the tangent of 30 degrees, 0.577. That's just the tangent of 30 degrees. So find R here. What's R going to be? It's the inverse tangent of 0.364 over 0.577. Sounds about right. 3225 is correct. Now, let's go back here a second. I'm going to call this angle A and this angle B. This was just the tangent of angle B. This was just the tangent of angle A. Right? So what we just found there for R is the inverse tangent of the tangent of B divided by the tangent of A. Let me prove to you that that works. So inverse tangent of the tangent of 20 divided by the tangent of 30. And we get 32.23. This is technically more precise because there's no round offs in it. You know, the 0.577 and the 0.364 were round off. That was really 0.3637. So that's actually more precise. But that is a formula given in the book, is that R is the inverse tangent of the tangent of B divided by the tangent of A. That's why I chose that thickness, or that height, to be 1, because this is just the tangent of 20 and the tangent of 30. This length here, which we're going to call L, is then the square root of 1 squared plus 0.577 squared plus 0.364 squared, right? $1.211. So I can use that to find T, which is right here. T is going to be the inverse cosine of 1 over 1.211. .33 degrees. Well, again, let's look at that. This was just the tangent of 30, and this was just the tangent of 20. There was tangent of A and tangent of B to get this number. So T can be the inverse cosine of 1 over the square root of 1 squared plus tangent of A squared plus tangent of B squared. Let me show you what I mean. So second cosine, inverse cosine, 1 divided by square root of, now 1 squared is just 1, so I'm just going to put in 1, times tangent of A would be tangent of 30, close that parentheses and square it, plus tangent of B is going to be tangent of 20, close that parentheses and square it. We get 34.32 degrees. Again, that's more precise because there's no round outside. The book does not actually give this formula. What the book uses is, instead of that formula, it uses the length across here, because that length is actually easier to find. You don't need that one. That length across there is the square root of tangent of A squared plus the tangent of B squared. Just this dimension and this dimension. And then it does an inverse tangent to find T. Is an inverse tangent of that over 1. Well, we don't need to divide by 1, right? So we take that out. The adjacent side is the 1. So that's what the book uses to find T. Well, that's why I showed you the other way first. These formulas here confuse the heck out of me. I am not going to memorize them. What I'm going to do when I do these is exactly what we did up here. I'm going to pick a dimension for a thickness, or if there's one given, I'm just going to use it. And then I'm going to use that thickness to find these theoretical dimensions. And then I'm going to proceed to solve it just like we did yesterday when we had those dimensions. I don't use those other formulas. I never use them. I throw them out there because there are some people that latch onto them and really like them. I'm not one of those people. And if you do really like those formulas, there. Okay. If you do really like those formulas, you can actually apply them to the types of problems we were doing yesterday where you have all the lengths. The only thing you can't find using these formulas is the length of bore. You always have to go back to that Pythagorean theorem for that length of bore. But let's say you have a problem like this. I'm just going to draw out the box. I don't know why my box sits at a different angle every time I draw it, but it does. So if I tell you that this here is 1.5 inches, this here is 0.9 inches, and this one I think is 0.75 inches. I can do this if I want to get back to those angle formulas. That's angle, that would be angle B over there, not angle A. This would be angle A. Now again, this is one, if you don't like using those formulas, pay no attention to what I'm about to do. But I can now find angle A. Angle A is just the inverse tangent of 1.5 over 0.75. So 63.43 degrees. Angle B here is the inverse tangent of 0.9 over 0.75. $50.19 degrees. And now you could go throw them into those formulas to find our rotation and tilt. R is going to be the inverse tangent of the tangent of 50.19 divided by the tangent of 63.43. Personally, I wouldn't do it that way. I would just do the inverse tangent of 0.9 over 1.5. To me, that's easier. But there are some people that like having those formulas. Come out to 30.96 degrees, approximately. 3.97 you're getting. Technically, in this case, since we were given the lengths are more accurate because these angles are rounded off. But you come up the same way. I used the lengths. I cheated. I didn't feel like punching that whole thing in the calculator. Sure. Any questions? Okay, I believe this is taking us pretty close to the end of this packet. I think tomorrow I'll have to get you a new packet. Yeah, well, I want to. You guys need me to get you. You guys paid for 16 weeks. We're giving you 16 weeks.
These other two I know that I'm not sure they want their money. Oh, that's true. Well, David wants his money.
We've got all sorts of fun left to have. So page 401 to 404, I think that's the end of that packet. Okay. 1 through 16, technically 1 through 15, the odds, if you do those 8 problems, that would probably be enough to satisfy scratch your itch. Tomorrow there will be a quiz on compound angles and drilling.